if the distance between the lemon that falls and the ground is 3.15 meter, then we need to tell that how much time does it take for the lemon to reach the ground. And the next question is that what is the lemon's speed just before hitting the ground. And I'm sure after watching this video you'll be able to give the answer comfortably. So we'll discuss this question at the end of the video. Welcome to STEM Professionals. In this video we'll discuss three topics. The first one is freely falling objects. The next one is effect of air resistance. And finally the characteristics of free fall. So let's start with the video. So this would be the final topic for the second chapter, freely falling objects. So what are freely falling objects? Now it is the motion of object falling freely under the influence of gravity. And Galileo was the first person on the planet Earth that showed that falling objects move with constant acceleration. And Galileo also showed that objects with different weight fall with same constant acceleration, provided air drag or air resistance should be very less that you can ignore it. And in the year 1971, astronaut David carried out an experiment to demonstrate the discovery that Galileo made. Now let's see that experiment with the help of this video, which is provided by NASA.
Jim, we copied both solar wind and penetrometer drum in the ETB.
Not quite yet. I haven't put the solar wind in yet, but I will shortly. I want to watch this. Joe, you have a good picture there. I've got
beautiful picture, Dave.
Well, in my left hand I have a feather. In my right hand a hammer. And I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago who made a rather significant discovery about falling objects in gravity fields. And we thought that where would be a better place to confirm his findings than on the moon. And so we thought we'd try it here for you. The feather happens to be appropriately a falcon feather for our falcon. And I'll drop the two of them here and hopefully they'll hit the ground at the same time. How about that? It proves that Mr. Galileo was correct in his findings.
So free fall is the best example of motion with constant acceleration. Now let's move to the next topic, effect of air resistance. Now here you can see there are two cases. In case 1, a sheet of paper and the ball is dropped from the same height, and we observe that paper drifts slowly as compared to the rubber ball. Now if you see the case 2, in the case 2 the paper is folded like a ball, and then both object is dropped from the same height, and we observe this time the ball of paper and the rubber ball reach the ground in nearly the same time. So what is the difference in these two cases? Just pause the video and think. Now in case 2, when the paper is folded, the effect of air resistance on it was greatly reduced because the surface area, contact surface area, this contact surface area is reduced, and due to this the air resistance is reduced, and thus the paper ball and the rubber ball reaches the ground nearly the same time. Now one thing you should note, that if you drop a feather and a coin in vacuum, then both fall at same rate. And the reason is that air resistance is 0 in vacuum. Now let's move to the next topic, which is characteristic of free fall. So let's discuss what exactly mean by free fall. Now the word free in free fall, it means free from any effects other than gravity. Thus, the free fall is the motion of object subjected to the influence of gravity. Now suppose there is an object and it is thrown in the upward direction like this, and there is another object, it is thrown in the downward direction like this. This is case 1, case 2. Now which of these cases would be a case of free fall? Think. Now both of these two cases are free fall. It doesn't matter the object is thrown in the upward direction or in the downward direction, it is a case of free fall. So here you should note one thing, that an object is in free fall as soon as it is released, whether it is dropped from rest, thrown upward or thrown downward. It will be a case of free fall. Now when the object is in free fall, then it moves with a constant acceleration. And what is the value of that constant acceleration? Now we usually denote this constant acceleration with the symbol g, and the value of g depend on the Earth's surface. Like if you are at North Pole, the value of g is 9.832 meter per second squared, or in Hong Kong the value of g is 9.793 meter per second squared. But throughout this series and in the coming series, we will take the value of g as standard, the value of g as 9.81 meter per second squared, because this change is very less. So we are just taking and this value which we take in this series, and in the coming physics series we'll take the value of g as 9.81 meter per second squared. Now we'll discuss the final concept on free fall, and then we'll get back to the question that I discussed in the starting of the video. Now while solving questions, if you choose a coordinate system with positive x direction in the upward direction like this, then the value of acceleration a is given by negative of g, because the direction of acceleration due to gravity g is always downward, and you have taken this as your positive x direction. So this would be the acceleration would be negative g. Now if you choose your coordinate system like this, if you choose this direction to be your positive x direction, then in this case the acceleration is given by a is equals to positive g. So this was the concept. Now let's get back to that question. So this was the question, and here we are given that a lemon drops from this tree and falls on the ground. Now the distance between this lemon and the ground is 3.15 meter. So before solving this question, let me first define the coordinate system. So this is our coordinate system. This is a positive x direction, and this is the initial position x0 is equals to 0 here, and this is the final position xf. Now in this case the acceleration due to gravity will be positive g, because we have taken the positive direction in the downward direction. Now there are two parts. In the first part we have to find that how much time does it take for the lemon to reach the ground. Since it is a case of constant acceleration, so we can use this equation, which is given by x is equals to x0 plus v0 t plus half at square. Now here you can see that initial position of the object is 0, so this term would be 0, and since it dropped from rest, so its initial velocity v0 will also be 0. So we can write that x will be equals to 1 over 2. Now a is g here, so g t square. This would be the equation. Now we need to calculate the time, so we can write that t will be equals to under root 2x over g. Here this x is the final position and this final position we have 3.15 because this distance is 3.15 meter. So we can put it here. The value is 2 times, this is 3.15 meter, divide by g is 9.81 meter per second squared. Now we can solve this by using our calculator, and we'll get the value of time to be 0.801 second. So in this much time period, the lemon will fill on the ground. Now in the next question we have to tell the lemon's speed just before it hits the ground. So this was the A part. Now we'll be solving the B part. For that we can use another equation of motion that we studied earlier, which is V is equals to V naught plus GT. Or other way around, you can use another equation, which is V square is equals to V naught square plus 2 times A times delta x. Now since the initial velocity for the lemon is 0, so this term would be 0, and here also this term would be 0. So that would be V will be equals to GT, and from this equation V would be equals to under root 2. Now acceleration in this case would be g, so 2 times g times delta x. Now you can put the values here also or here also. You'll get the same answer. So let's first put in this equation. So V will be equals to the final velocity at this point just before hitting the ground. G is 9.81 meter per second squared times t is 0.801 second, and here we have V equals to under root 2 times g is 9.81 meter per second squared times delta x. Delta x is xf minus x naught, which is 3.15 meter. Now on solving this, we'll get this velocity to be 7.86 meter per second, and from here also we'll get the same velocity, which is 7.86 meter per second. So you can use either of the equations. Now from this question we have some observation that we're going to discuss now. Now here you see that this x naught and v naught, this is 0 because its initial position is 0 and initial velocity is 0. So we have left out that x is equals to half gt square. Thus we can say that the final position is just the function of time. This g is constant here, so it's just a function of t square. Now there are two more observations that we can see from this equation and this equation. Now here we see that velocity is a function of time here, and it's a linear function, and from here we can say that velocity is a function of position because this g is constant, so this is a function of position. So these are the three observations, and based on these observations I'll be giving one question to you, and this is the question, and this is a practice question you have to do on your own, and you have to write the answer in the comment box below. So the question is that you have to consider the distance the lemon drops in half the time required to reach the ground, that is time is 0.801 divided by 2. Now for this condition, is the distance greater than, less than, or equal to half the distance to the ground? Initially the distance was 3.15 meter. So for this case, will this distance be equal to, less than, and so on? That you have to see, and you have to write the answer. Now for the B part, they're asking that you have to find the distance of the lemon drop in this time. For that you have to use these equations. So this is all with this video, and in the next video we'll discuss few more questions on free fall. So goodbye.